It could be people are living longer. I mean, one of the effects of modern medicine is that people live longer with disease, Alzheimer's included. But it's absolutely a consequence further of our overall metabolic milieu that we put ourselves in a position where we're making our brains insulin resistant, and thus they're going hungrier and hungrier.
There's a study you talk about, which you've cited before, that shows that if you move visceral fat from an obese animal to a lean animal, this immediately caused insulin resistance.
Yeah, in the animal that received it.
Okay.
Yeah, so just to be clear, if we took what they did in this study just to reflect why, or that different depots of fat are harmful. And so the human body has two distinct fat depots, and you and I described them: subcutaneous, which is the fat beneath the skin, or visceral, which is the fat tucked within the organs of the abdominal space. And if you move subcutaneous fat,
which is like the belly fat.
The belly fat, and from one animal to another, you couldn't do this in humans. If you move belly fat, if you will, or subcutaneous fat from one animal to the other, the animal's very healthy. It's no problem. Subcutaneous fat is inert. It really is just sort of hanging out there and minding its own business. But in that same study, if you move the visceral adipose over, now all of a sudden that animal that got that extra dose of visceral fat is going to become sicker. It's going to become more insulin resistant and diabetic because you've increased its visceral fat, the amount of fat that it has in that space. The body wants to limit the amount of fat that it has there because if the fat grows too much, you can physically start compressing and squishing organs that you need to be functioning, like the kidneys and the intestines.
Have you seen Brian Johnson? And he's become a bit of a poster child for the subject of longevity.
Right. Well, I want to address this because this is a real person. So I want to address it very politely and diplomatically. I think that I want to distinguish the difference between longevity research and science, which is a very real, living, breathing field. And I'm proud to know individuals who are longevity scientists, and distinguish them from longevity. You said poster child, so the gurus of longevity, and that's not the same thing. So what I say, I don't mean it to be an indictment of longevity research, but I don't mind if people hear a bit of an indictment in my voice of the modern longevity guru approach. So these individuals, and he is certainly the most well-known, they do have the advantage of never really being able to be proven wrong. So there's an inherent problem here. But I will say that the application of being a longevity expert, or not a scientist, but a guru, and I don't mean for that to be negative, but it does have a bit of a negative sound to it, is that you have to rely on what I would call weak evidence. Now, what do I mean by that? So all of the approaches to longevity nowadays rely on either correlational studies or basic research, or animals and insect studies, and then extrapolating that results or assuming those same results will apply to the human. So let me briefly just mention my concerns with correlational research. So the longevity guru will say, correlational evidence suggests that people who eat meat die more. Well, a correlational study is, by my estimation, some of the weakest evidence that you can ever generate. A correlational study would just have someone come to your home and say, Stephen, can you please answer this survey about what you eat? You answer the survey. You may lie. You may not remember. You may have things that you don't even think about including, like, for example, that you're part of a very well put together religious organization. And I actually use that example very deliberately because people who are known to be part of good, tight social circles, like a formal religious group, always live longer than people who don't. Maybe you're really lonely. Loneliness is a greater contributor to death than cigarette smoking, and it's not even close. So there could be things on that survey that you just cannot capture, and yet we end up making a conclusion. And so all of that correlational evidence is deeply flawed research, and yet that becomes the basis for the longevity guru to determine diet. So my view on longevity is a metabolic view. No surprise. I'm a metabolic scientist, and I don't mind someone sort of smirking at me declaring that or admitting it. But I'm somewhat justified. Just by way of setting the stage, the birth of the modern longevity research, if it didn't start, it was heavily influenced by the work of a woman named Cynthia Kenyon, Kenyon. Cynthia Kenyon was one of the kind of she really did, in my mind, kind of give birth to the modern longevity focus. What her lab found using an insect model, and this is again a problem with the longevity gurus, is that they rely on insect data, for example, but it was compelling what she found. I think it was worms. She found in worms that if they restricted the glucose that the worms were eating, they would live 50% longer, or some fantastic increase in how long the animals lived. That kind of gave birth to the idea of fasting being beneficial, but it also allowed her lab to start playing around with some of the genes of these little insects. And when they started knocking down or underexpressing some of the genes involved in insulin, they didn't have to restrict the food. The animals just lived longer. And so that touches on this metabolic aspect. And everyone nowadays is really interested in autophagy. Autophagy is a term for a cell essentially cleaning itself out.
Which is typically associated with long fasting.
Yeah, yeah. In fact, yes. So that is partly why fasting has been so embraced within the longevity community. It's because if you can promote longevity, or autophagy rather, if you can promote autophagy, the cell keeping itself cleaned out, that is thought to be a key contributor to longevity. So autophagy equating to longevity. I don't disagree with that. I think that probably is a very valid view. Then the question comes, well, how can I control autophagy? Well, there is a humble hormone that comes from the pancreas that has a very powerful effect on autophagy called insulin. So as much as people are fasting, what's the value of fasting and reducing autophagy? It's because insulin comes down. Now, what becomes interesting is what happens if you were to put someone, allow them to eat calories, but the calories are such that their insulin is staying low and they're making ketones, in other words, a ketogenic diet. You also enable autophagy. There was a very well done animal study finding that they didn't have to restrict calories and fast the animals. They could let the animals eat as much as they wanted, but it was a ketogenic diet. They lived significantly longer than their other litter mates that were eating the normal high-carb chow, similar to what humans eat nowadays. And so autophagy probably does matter for longevity. All the more reason to keep your insulin in check, because insulin is a powerful inhibitor of autophagy. So as much as we have longevity gurus who are taking thousands of dollars worth of supplements, I can't help but look at that and think, just control your insulin. That within every cell, there's this battle. There's a yin-yang of growth and death, or building and breaking, to say it a little more politely. In fact, that is metabolism. The very word metabolism encompasses anabolism, which is anabolic or building up, and catabolism or catabolic, which is breaking down. The key to a healthy, growing, living cell is this nice ongoing balance of build and break, build and break. You have to build something up and then modestly break it down, and then you build some things up again. And autophagy is a very important part of that breaking cycle within the cell, that, hey, it's time to get rid of some old parts, and now we'll rebuild some of that again. Now we're going to break down these parts and rebuild it. Insulin is the key to that process. If insulin stays high for too long, you never allow the catabolic or the breakdown. This is one reason why insulin is so facilitative to cancer. Insulin wants things to grow. Cancer is a disease of growth. We don't ever let the cancer start to break down. Insulin won't let it, in part.